Okay, so we are getting into the part of statistics that actually, when you take stats in college, this is probably what you will deal with a lot more than the probability end of it. You will do some probability, but this is the actual meat of a statistics class. And statistics is used in all different industries. It's definitely used in education. It's used in medicine. It's used in any science, psychology. If you're a psychology major, you will take more than one statistics class, believe it or not. And so it just gives you probability of certain events happening. So there's just some definitions. Let's go over those really quick. So statistics is just a way to summarize and compute sets of data. Measure of central tendency, that's when we're looking at mean, median, mode. What's the mean is the average. Those are the three central measures of that central tendency: mean, median, and mode. Mode happens the most often. Median is directly in the middle of all of your data set. And mean is the average. Okay, also known as mean, also known as the average, it is a sum of n numbers divided by n. That mean is denoted by, we call it x bar, and it's just an x with a line over it. Okay. The median is the middle of the numbers when they are placed from least to greatest. So if you have an odd number of data points, that's easy. You just count to the middle. Make sure you have the same number of values to the left and to the right. If you have an even number, you just take the average of your two middle numbers. The other thing I want you to add in here is range, because that will come up too. And it's just the difference between the biggest and smallest. Huh? Oh, never mind. We'll get to it. Okay, yes. Thank you. Way to read ahead, girls. Okay, mode is the number that occurs the most often. So when you did stats before, it was probably in 7th grade is the last time they really have you look at any kind of statistics at all. So you definitely did mean, median, mode at that point. But okay, so for both race A and race B down below, we are going to find our mean, median, and mode. So you need to have a calculator out if you have one. You definitely can use a calculator in statistics. Don't have to, but it certainly makes life easier. So the way you are going to find the average is you're going to add those up. 4 plus 7 plus 8 plus 8 plus 9 plus 9 plus 10 plus 11 plus 12. And you're going to divide it by how many you have. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. So just going to add those up. 4 plus 7 plus 8 plus 8 plus 9 plus 9 plus 10 plus 11 plus 12 gives me 78 over 9, which is an average of 8.67. And depending on what you're doing, you can either round to 2 places or to 1. Typically, you're going to want to round to 2. It's just a good overall average to keep. So for race B, I'm going to add those up again, and I get 5 plus. Is that what it is? 69. And I'm still dividing that by 1, 2, 3, 4, 5, 6, 7, 8, 9. Gives me an average of 7.67. Okay, so median. Median is what happens when we list them from least to greatest, and we find the one that's directly in the middle. So we have 9 values, so right in the middle is going to be the 5th number. It would have 4 values below it, 4 values above it. So 1, 2, 3, 4, 5. So our median is going to be 9 for race A. 1, 2, 3, 4, 5. It's going to be 8 for race B. Easy enough. Mode is the number that occurs the most. So for race A, that is going to be 8 and 9. There's not one that they both occur twice. Okay? And mode for race B is going to be 8. It occurs 3 times. Okay, so measure of disbursement. It just tells you a statistic that tells you how spread out your data values are. And that goes right along with the range. So the range is just the difference from your smallest value to your biggest value. So, for example, the range for this one would be the difference between 4 and 12, which is 8. This one, the range is from 5 to 11, which is 6. Okay. There will be something we talk about called an outlier. An outlier is if you have a value that is completely outside of that range, right? So sometimes we have outliers with test scores, right? Everybody has like a 60 and up, and then there's a 12. That would be considered an outlier, right? Okay, so standard deviation, which is something we're going to get into, is the typical difference, or deviation just means change. Typical difference between a data value and the mean or the average of that data set. So how far are you from the average, either above and below? And there is a commonly regarded distribution that's just called normal distribution, and it results in what's called a bell curve. And we'll talk about that in a second. All right, so here's how standard deviation is calculated. Okay, now there are ways to do this on your calculator. I'm kind of old school with this, and I just do it by hand, and it's important to know both ways. So, but all your calculators are going to be different. You can also do it in a Google spreadsheet. If you get this on a test, you won't have access to a Google spreadsheet. So you would have to know how to do it either on your calculator or by hand. So first thing you're going to do is determine the range and standard deviation. So our range for race A is going to be 12 minus 4, which is 8. And then we're going to work on the standard deviation. Standard deviation takes some space, so that's why you have the boxes down here. The range for this will be 11 minus 5, which is 6. Okay, so we already determined what you need for standard deviation is you need the average of your data set, which we already have from the other side, right? And the average for the first one was 8.67, and the average for the second was 7.67. Okay. You could, for ease of life, round that up to 8.7 and 7.7, but it's going to make your standard deviation off a little bit. So what you're going to do is you're going to take each of these numbers in the data set and find the difference between that and the average. How far away is it from the average? Okay, so this is the way you're going to do that. You're going to do 4 minus 8.67 and then square that value. Okay, so 4 minus 8.67 is negative 4.67, and then you're going to square that. What happens when you square a negative? It turns positive. So the difference is irrelevant because the square is going to undo that negative. Okay, so 4.67 squared is going to be 21.81. And you're going to repeat that for all of these values. Do you remember this, Paula? 7. Do you remember standard deviation? Oh, good. Okay, so this would be negative 1.67 and square it. Okay. When you have 2 or more of the same values, you can actually take that amount. So you've got 2 8s, for example. 2 times 8 minus 8.67 squared. Now, if you're going to do that, you need to do things in correct, here we go again, order of operations. If you don't, you're going to have a completely different answer than what you want. Okay? So you're going to do the difference. So 8 minus 8.67, get that answer, square it, then double it. Because that would be, if I wrote it twice, I would have to add those together. Right? So that you would get 0.90. Two of them, so I get 0.90. Just shortens up your math a little bit. Okay, so keep going and finish that out, and we'll come back and I'll show you what to do when you get all those. So we're trying to find an average that actually resembles the distance that every value is from that average. So now that you have these, you're going to total those up and find that average. Plus 0.22 plus 1. Okay, so I get 44.5. 44.01. Somebody check my math. 1, 2. And remember how many, now remember that you had these doubled over here. So how many numbers are still in the data set? There's still 9. So we have to divide that by 9. Okay, but then we need to undo this square root that we did also. So you're going to actually square root that whole thing. Now that you can do as one step in the calculator. That's actually fairly easy. So you can go second function square root, 44.01 divided by 9, and you get 2.21. And the way we write standard deviation is a little O with a little tail on it. Can you see it? 2.21. Okay. So what that means is that is how far, on average, the difference is for those. So we're just going to make sure we know how to calculate standard deviation. The next section is on normal distribution. Okay? So I would like you now to try race B on your own, and then we'll come back and check it. So that is finding standard deviation. You should have gotten around 1.83. Just remember when you're dividing, even though we grouped these back up here, and you only have 6 rows of information, you had 2 values of 6 and 3 values of 8. So you still have to divide by how many you have in the data set. Okay? All right, that's it. Okay, so we need to talk about an outlier, and one that is, that's a value that's a lot more or a lot less than all the other values in the set. So we're going to work through this problem. I'm not going to record all of it, but you're training for a triathlon. The miles that you ride your bike for 7 weeks are shown below. Okay. If I add in part B, we're going to add in number 3, the 3 miles, and see what that would do to all of our values. So you can go ahead and find mean, median, mode, range, and standard deviation for A, and then repeat it for B. We'll see the difference. Okay, so there's your mean, average, mean, median, mode, range for, and your standard deviation for the first example. The big thing that's going to change is that range is really going to change when we throw the 3 in there. Now let's see what it does to the standard deviation too. So before I even calculate the standard deviation, let's look at the total. Look at the difference. You got 24.86 was your total of all your squares here. Down here, you're about 10 times that much, 244. So what's that going to do to your standard deviation? It's going to make it bigger or smaller? Way bigger, right? So that's where you're really going to see that difference. So standard deviation is going to be the square root of 244.88. This time we're dividing it by 8. So your standard deviation is 5.53. So that really changed that between here and here. Okay? So you can go ahead and fill in the chart down below too when you get done with that. So just looking at our chart here, which of these measures of tendency does the outlier affect the most? Range is huge, and the standard deviation, right? It affects the average a little bit, but most of that difference comes because you've got to find the difference between 3 and 16.88 and then square that, which is huge. So the most would be the range and the standard deviation. The least would be the mode, right, and the median. That didn't change a whole lot. Okay. And so you have a much larger range and increased standard deviation. Okay, and in the next section, then we'll start working on normal distribution, and you'll see how this actually plays out.